Next our topic is switching modulator. Okay, so the switching modulator is used for generate the AM signal. Okay, so in this modulator we can replace the multiplication operation with the switching operation. Yes, right. So for that here we using the elements. One is summer, diode, next one is band pass filter. Okay, so here M of t and C of t is added by the summer, and that will be is V1 of t. So V1 of t equal to M of t plus C of t. So that will be given to the diode. So here diode used as the switch. Okay, so that means it will be open circuited for the reverse bias and closed circuit for the forward biasing. Okay, so when this one is the ideal diode, then in the forward biasing condition diode is on condition, then it creates the link between the V1 of t to V2 of t. Okay, when it is reverse biasing condition, it is off condition, that is open circuited, then there is no link up between the V1 of t to V2 of t. Yes, right. Okay, so then here you see, here this diode will be act as a switch when is depends on the C of t. So carrier signal having the positive off cycle, that is greater than 0, then diode is on condition. Okay, when C of t is carrier signal is negative off cycle, that is less than 0, then this diode is off condition. Okay, so suppose here we having the carrier signal is pulse. Okay, so this type of signal. Okay, so for the positive off cycle diode is on condition, for the negative off cycle, that is diode is off condition. Okay, so then the output is passing through the band pass filter. Okay, so this band pass filter is tuned with the from Fc minus Fm to Fc plus Fm. Okay, so in between that frequencies will be allowed by band pass filter, remaining all the frequencies are rejected by this filter. Okay, so the output of this one is V0 of t, band pass filter output is V0 of t. That V0 of t is proportional to our message signal M of t. Okay, so here we having one graph between the V1 of t to V2 of t, V1 of signal to V2 of t. So here linearly increases. Okay, that means when C of t is greater than 0, diode is on condition. Okay, what we having the input, that will be appeared at the output of the diode. Okay, so that means here diode output is V2 of t and diode input is V1 of t. So when this carrier signal is positive off cycle, that is greater than 0, V2 of t equal to V1 of t. Okay, so that means what we having the V1 of t, that will be at the output of the diode. Okay, so that means what we having the input, that will be output. Input is there, output. Okay, so that means linearly it will be increases. So here V1 equal to V2, thereby the slope of this wave, this line is, the signal is 1. Okay, so next coming to negative off cycle, the diode is not functioning, then V2 of t is 0 value. Okay, V1 of t negative cycle, then our V2 of t is 0 value. Okay, next coming to here we having the operation of that one. Okay, so when C of t is greater than 0, diode is forward bias condition, then V2 of t equal to V1 of t. When C of t is less than 0, diode is reverse bias condition, then V2 of t equal to 0 value, and V1 of t equal to, we know that M of t plus C of t. So AC cos 2 pi FCT plus M of t. Yes, right, where amplitude of the message signal is 4 less than the carrier signal amplitude. Okay, so now mathematical equation for V2 of t equal to V1 of t, where the condition is C of t is greater than 0. So V2 of t equal to 0, where the condition is C of t is less than 0. Yes, right? Okay. Next, coming to here, you see here output of the diode. Output of the diode is when it is on condition, signal is passing. Okay, V1 of t is passing, and diode is off condition for the negative off cycle. Then V2 of t is 0. Okay, so that means it look like a periodic pulse. Okay, so this is the operation output of the V2 of t. Yes, right? Diode output. Yes, right? Okay, so that means here this periodic pulse is repeated with the carrier frequency, that is fc. Okay, so then t naught equal to 1 by fc. Okay, so that this periodic pulse we can call as the Gaussian function, that is represented with gp of t. Gp of t. So then V2 of t equal to, we have the equation, that is V1 of t into Gp of t. Okay, so this is diode output and V1 of t. Okay, so next, coming to Gp of t, this one is the periodic pulse train. Okay, so you can represent this one in terms of the Fourier series. Okay, now write the equation of Gp of t equal to 1 by 2 plus 2 by pi summation n equal to 1 to infinity minus 1 power n minus 1 by 2n minus 1 cos 2 pi fct of 2n minus 1. Here V2 of t is equal to, we know that V1 of t into Gp of t. Okay, V1 of t we know that is m of t plus AC cos 2 pi fct into Gp of t. So Gp of t is this one. Okay, so next substitute here n equal to 1 value, n equal to 2 value, n equal to 3 value. Okay, so now here if you substitute n equal to 1, then here we having 1 by 2 plus 2 by pi. Okay, next n equal to 1 minus 1 whole power 1 minus 1, that is 0. Minus 1 power 0 is 1. Okay, 2 into 1 minus 1, so 2 into 1 is 2, minus 1 is 1. Okay, 1 by 1, that is 1, cos 2 pi fct. 2 into 1, 2 minus 1, so cos 2 pi fct. So first term is n equal to 1 cos 2 pi fct. Next n equal to 2, n equal to 2, then what we get, 1 by 2 plus 2 by pi. Okay, next minus 1 whole power 2 minus 1, that is 1 only. Next 2 into 2 4, 4 minus 1 is 1, 3. Okay, minus 1 by 3 cos 2 pi fct. 2 into 2 4 minus 1 is 3, so minus 1 by 3 cos 2 pi fct 3, so that is cos 2 pi 3 fct. Okay, so this is n equal to 2 value. N equal to 3, 1 by 2 plus 2 by pi. Next minus 1 power 3 minus 1, that is 2, minus 1 square is 1 by 2 into 3 6, 6 minus 1 is 5, 1 by 5 cos 2 pi fct. 2 3 is a 6, 6 minus 1 is 5. Okay, cos here 2 pi 6 fct. Yes, right? Sorry, 6 minus 1 is 5, 5 fct. Yes, right? Okay, so then here first term is cos 2 pi fct minus 1 by 3 cos 2 pi 3 fct plus 1 by pi cos 2 pi 5 fct. So this one is the periodic representation of the Gp of t. Now substitute that value in this V2 of t. So then V2 of t equal to, here we got the m of t plus c of t is cos 2 pi fct and into this Gp of t value. Okay, so now V2 of t equal to, here you just multiply this into this one. Okay, so then first m of t into 1 by 2, that is m of t by 2. Next plus AC cos 2 pi fct into 1 by 2, AC by 2 cos 2 pi fct plus next m of t, that means 2 by pi into m of t cos 2 pi fct minus next AC 2 by plus 2 by pi AC cos 2 pi fct cos 2 pi fct, cos square 2 pi fct minus next 2 by pi 2 by 3 pi m of t cos 2 pi 3 fct next next మళ్ళీ minus ac by 3 cos 2 pi fct into cos 2 pi 3 fct. Okay, so then passing this signal v2 of t through the band pass filter. So band pass filter is tuned for the fc minus fm to fc plus fm. So thereby v2 of t equal to, we got ac by 2 cos 2 pi fct plus 2 by pi m of t cos 2 pi fct. So remaining all the terms are rejected by the band pass filter. These two terms are allowed by the our band pass filter. Yes, right? The output of the band pass filter we represented with v naught of t, that is equal to ac by 2 cos 2 pi fct plus 2 by pi m of t cos 2 pi fct. Okay, so this here you just take our ac by 2 as the common, then it is ac by 2 1 plus 4 by pi ac m of t cos 2 pi fct, where this one is Ka term, that is sensitivity, amplitude sensitivity of the switching modulator. Okay, so this is in the standard AM equation. Okay, next coming to our waveform, this v naught of t is proportional to the our m of t. So in this way we can generate the amplitude modulated wave using the switching modulator. Okay, next coming to the waveforms. So here this one is the modulating signal and this one is carrier signal. Okay, so this according to modulated signal, carrier signal amplitude will be varied. Okay, so this is our amplitude modulated wave. Okay, next coming to the spectrum of the our AM modulated wave. First you take the output, that is v naught of t, one center line. Okay, so next after that locate the fc values. Okay, for positive side and negative side. Okay, fc having the amplitude, that is ac by 2. So in the equation, you observe the equation, then you find out the amplitude of the carrier signal. Okay, so then that will be located here, positive side and negative side, plus fc minus fc. Okay, next after that find locate the amplitude of the side bands, that is ac by 4. Okay, next you find out the positive side frequencies and negative side frequencies, that is fc plus fm and fc minus fm, and here minus fc minus fm, minus fc minus of minus fm, that is minus fc plus fm. So this one is our usb. Okay, so this one is lsb and this one is lsb and this one is usb.